So hello everyone, and welcome to this session of Intelligent Soft Matter. So what we try to organize is a workshop on a very unusual workshop, and the structure of this workshop is also the topic is unusual and the structure is unusual. This is the website, what you see on the screen. And this is about intelligence of matter, and it is not, it is emerging field, so it is not yet well developed, and it will be maybe in future one of the direction of the soft matter. And since not much it was done in this field, what we are planning in this field, and what we see what can be done from different perspectives. So we have people working with materials and soft matter and experimental side, and we have people from sensors and nanoparticles and how to sense the environment. And we have also people from decision making, artificial intelligence, which also a different field. So there is a mixture of different profiles. And today, what we wanted to do, because the topic is very unusual and new, here there is a description, and also we have a program, and we have also profiles of the people. So today, what we wanted to do is to meet in this meeting should be also an unusual format. It will have an unusual format that it is not only presentation of the talks, but also collaboration and initiation of the collaboration and discussion. And we can and to initiate this discussion and to make it meaningful, what we did is we wanted to analyze the contributions, and also that people who will join, that they may know each other before the meeting, and also to have some ideas of other people, and also of other directions, and also other ideas of people what they can bring to this meeting, and with whom they can meet, and what they already, if we start writing a paper, for example, we have in the plan the paper on, so in those sessions, we have a plan to write a perspective paper. And when we write this perspective paper, we should already prepare and to be prepared and to prepare some a part of this text, and to be ready to collaborate with people, because still we have very short time during the meeting. That's why I suggest, so we have this session, and additionally we have a session on grant writing session, and this is will be organized by IKEA, and also with this will be a session traditional grant writing. And and last day we will have idea generation session, which is more open, and it will be prepared, which is what we are doing now. We will be prepared in collaboration with two guests. One is Daniel Friedman from California, and he is director of the Active Inference Institute. And today we have another guest, is Tobias Koen from Netherlands, and he is as a CEO of the company Knowledge Pixels, who is behind of nano publications. So why this is important? So we have in here, what we want to do is to generate some ideas before the meeting. This is the goal. And one side, we will use artificial intelligence and the modern tools which allow not only to present your directions, but also to get insights from other fields through this automatic process. And this is this idea generation process through FieldSHIFT, and this will be presented by Daniel Friedman. And on the other side, if we have those ideas, we can register those ideas as small pieces of information with a name, and this can be a nano publication, which can be in a machine readable format, and that can also allow to build on top of this piece of knowledge. So then what we to see how we can merge all those new technologies, and to see how it is possible. So first of all, I would like maybe to that maybe our guests will tell a little bit about themselves and also about these tools. So first of all, we start with Tobias, and then with Daniel will lead maybe like this. So Tobias, do you want to present your tool?
Sure, yeah. So, well, I can just very quickly introduce myself. I'm Tobias Koen. I'm actually no longer based in the Netherlands. I'm still affiliated with the university there, but I'm now in Zurich, Switzerland, and we have now our small startup called Knowledge Pixels. And yeah, as Vladimir already said, we are focusing on this concept and the technology of nanopublications. Yeah, I know. Do you want me to now already give a quick demo?
If you give maybe 1 or 2 minutes, that's the concept of this nanopublication, and then we go further, because then we will discuss how to include it, and after this, how to merge it later. But if you just tell what is the concept, how it works, and that will be enough.
Okay, yes, of course. So as the name says, a nanopublication is like a publication, but tiny. And on top of that, it's a publication. It's not just written in English or any natural language, but it's written in, you could say, a logic language. If you're a bit familiar with semantic web or linked data technologies, it's written in the RDF language, which means it's made of sentences where you have subject, predicate, object, and all the 3 of them are globally unique identifiers. So people around the globe can say things, and when they talk about the same thing, it will automatically connect. Yeah, if I may kind of simplify it a bit. So nanopublications are kind of these tiny snippets of such statements. In the simplest case, it's just a single such sentence with something is related with that thing to that thing. Like I know in medicine, it could be this gene has this kind of effect on this disease. Often it's more than one such triple, as they're called, because often statements are a bit more complex than just a simple triple. And that together, so these couple of statements then consist the main content of nanopublication, which is called the assertion. But then it always has some provenance to it, meaning you can state with another such triple where this came from. For example, because you had a study that delivered it, or because it was extracted from an existing paper or data set or whatever. And then it has some metadata where you can say who created it, with which tool, with a timestamp, with a license, and these things. And all that together then is an nanopublication. It gets a stable, persistent identifier of its own. And the thing that we are now working with, the thing that we are providing is that you're building a decentralized ecosystem for dealing with such nanopublications. So you can push them to the world, basically, to the nanopublication network, and it can then live at different places. So when you later, you or somebody else want to retrieve it again, you can. And because it has this formal structure, you can also ask very specific queries that can then precisely be answered for humans to consume, but also for machines and for applications to build upon. So we can also on the fly create new classes and relations, so we can create new vocabulary and then talk about it and make nanopublications. You have a tool for that that's called NanoDash that is supposed to be user-friendly, so it's still kind of cutting edge, so there's still a lot of work ahead of us. But anyway, so it's kind of a low threshold to publish these, and then you and others can query it again. And yeah, we're now in the first steps to kind of apply this more broadly across different domains and with connections to journals. And yeah, there's a lot I could talk about more, but I think I've already used up my 3 minutes.
Yeah, so that's exactly the purpose of this tool, how to use this tool. So it is a machine readable format, and this is very short and easy to publish. And this goes in the direction of the new trends of this language models. Then they come, and the process of publications, the dissertation writing, project writing, and those public large review writing, that becomes obsolete and already doesn't have much sense to have all this all this traditional legacy publishing system. So instead of this, it goes in the direction of very specific and personalized tools, and also in the artificial intelligence now becomes more and more it goes in the more and more in the direction of agent based. So instead of general tools for everything, so you will have an agent which will be doing some work or task very personalized for you and for other people. So you will communicate through the agent. And this is how we see how these nano publications can enter into this domain. And this is how we connect with Daniel from Active Inference Institute, because the whole institute is focusing on the development of those artificial intelligence tools that will be making those agents which will be making interaction between human and machine. And this is one of these examples how we can apply these two intelligence soft matter to this workshop, and we can just show how, at least again, this is a very early stage, but how this can be approached. Maybe now, Daniel, you can come up and show this tool and explain a little bit how it works.
Great. I'm going to share my screen.
Okay.
Okay. All right. Well, thank you, Vladimir, for inviting me, and it's been really fun to collaborate on these directions. Also, Tobias, that's very exciting about the nanopubs. I think broadly, this is going to be the unstructured text getting into where the structured information of nanopubs is going to supercharge it. But even today, I think there's some pretty fun and exciting, at least provocative, directions to explore. I'm gonna push this all to the GitHub link that's in the video description and in the side chat. Okay, so to kind of back up, and then we'll look at this on the open source GitHub. Last week, we had an applied active inference symposium at the Institute. And in those sessions, we kind of analogously had participant information, presenter abstracts, and so on. And so working with Vladimir, we had some discussions and we built some tools around like, what can we do to add value and context before the event? How can we start to think about templates and transferable tools and practices across different related or overlapping or even totally separate open science and participation initiatives? So we made this repo called Symposium. So Vladimir made a bunch of edits and commits to this before last week and recently, including adding in some open source language model methods. What I'm going to show is just a few more researcher side process accelerations, perhaps, using Perplexity. That's available through the browser at Perplexity AI. And here's using the API. So what I did here is I took the Perplexity folder that I had applied to the active inference symposium participants, and then adapted this in this folder called ISM stream for intelligent soft matter. So that's where everything that we're going to talk about today is in here. So this is just as the folder's named, it just meant different pieces for people to pull out and explore. And then also I'll note that this is all done in Cursor, especially as there was already a folder of this working for a different structure, but analogous tasks. Getting to this ISM stream content was like 10 to 20 total prompts and cursor updates. Okay, so in the inputs folder, Vladimir provided the information on the participants. And also there's a cat. So here's intelligent soft matter, and then there's speakers and participants, and they each have this open Alex and this works. So the works are some citations and bibliography, and the topics are topics of the person. Okay. So what the first script does is it researches the presenter. So everything goes into the outputs folder. Here's the presenter folder. So in a JSON and a Markdown, here are internet-based research subjects, all experimental research tooling, so it's hard to even estimate. Sometimes it's totally accurate. If it's little information in a common name, this isn't going to be very useful. If there's a ton of information and links provided, it's super useful. So this outputs a summary on the presenters, but I kind of wanted to explore the working with the participant information more. So that's what most of the following scripts are. So the second script 2, and all these are run with just from the ISM stream folder, just Python 3 and then the name of the script. So for the participants, started off with also writing a research report. I don't know if we can look up someone who's here now to see how accurate it is. But
yeah, Akile is here,
okay.
And it looks quite accurate.
Okay. So again, sometimes it's super accurate, sometimes double check. Okay, so wrote this research report. Then this is where FieldShift comes into play. So these are just sort of playing around with different combinatorics of what is possible. And also this is just using all by all folder iterating. So it's not using a database. It's hardly agentic in the sense that we could call any part of a computer pipeline agentic, like is a database search a search agent? I guess if we do think about it that way, then it is. But this is just using all by all iterating on these folders, which keeps it plain text and really available also for nanopubs and GitHub and all of this. So what FieldShift does, there's a folder called domain. So in this folder called domain, this is copying a folder out from a previous repo and live stream called FieldShift. That was based upon some work by Mike Levin's lab. So what domain has is it has these synthetic knowledge files. So they're just specific questions, examples, factual statements within a domain. So just some of them they're just meant to load up the context and just provide information on a synthetic domain. But you could imagine that could be like a person's record or an organization's record or a different kind of document. But here just being used just to say, these are just statements and open questions and problems and this happened this year, all those kinds of things for different domains. So what FieldShift does is it takes each participant's background and it will find, I didn't run this for every single participant, but we'll just run it in Cursor now. So this takes each participant's background and then basically uses Perplexity to juxtapose the researcher's background and the synthetic domain, and then asks what could they learn from the field and how could they contribute to the field. So this is Daniela Kraft and RX Infer. And then the way that, again, there's more sophisticated ways to do prompt engineering. But what's happening here is it just sending to Perplexity, here's the participant, analyze the bidirectional knowledge exchange between name and participant. Here's the profile of the participant, here's the knowledge domain, just copy paste. Each of these take like, so here, let's just look at this one that just was made. Here's what this person could learn from RxInfer. I mean, these are accurate parts of what they could learn from that field. How could they contribute to the domain? I don't know, but that's from and to. So that's field shift, and then that just iterates over whichever domains are in the domain folder. So it's like, here's statements about William Blake. That's 3. So that's the field shift. Okay. Then Vladimir provided a folder of catechisms. So catechism can mean different things, but in the project management setting, it's a set of question and answers that are aligned with project management, being a grant officer, program manager, these kinds of questions that are important to be addressing. So took this for shifted catechisms. Here, this was like one prompt from 3, copied 3 and said, okay, now with the catechism in at catechism folder, write that structure for each of these shifted fields. So now, with the Daniela Kraft blockchain bidirectional relationship, now it's going to write a catechism with that structure. So it'll take a few seconds. Then just while this one's processing, the other way to use a catechism here is for all pairwise participants, write a catechism that would reflect a complementary project using the karma gap. I don't know what it is, but that catechism format. So we'll look at, okay. Here's 5. So here's Daniela Kraft X Dong Xie. And then that is just saying, okay, now for these 2 participants, there's other ways that you could fill up the context window and everything, but just saying, here's how you write the document. Here's what we're looking for with document styles. Here's the template of the catechism. Here's the participant information. Here's their other proposals that we know from them. Here's their field shifted to and from, and then make a collaborative project. Okay. First, let's look at just the field shift blockchain. I don't know this person, but we'll see, they can see to and from blockchain. And then just last piece is the collaborative proposals. We'll look at it in GitHub.
Yeah, maybe I can also show the results when we were shifting the profiles of the people, because they are coming from different domains to the context of the workshop. It's intelligence of matter, and what was the outcome. So it was done with 3 steps. First step is to generate profiles of each person, and also the questions. Maybe if I switch to online now, I will show the outcome of this result. Yes, Danielle. Yes. Okay. This is here. So this is also in the same GitHub GitHub folder. So if you go here, so there is a inputs, and inputs are basically, they are taken from this is intelligence of matter and participants, speakers, and we have outcome is the publication taken from OpenAlex. So there is a publication directions, research directions, topics, and also citations. So this is provided in this format. So we have this as a basis, so we don't use any other information, and we can do it for any researcher. And after this, the question was, after we have a free site, generate profile of the researcher with respect to the field of intelligence of matter. Then we have researcher methods. It can extract the methods and also description of the methods from each profile. And additionally, we can do collaborative projects, and the projects depending on the catechism, what Daniel explained. So what, for example, we have European projects, they have a certain structure. If we have a American project or some other funding, then it will be completely different questions and different structure, and it will be different. So the catechism is here. So this is just a text file. And for example, if we have European grants, this is a certain structure. If we have, and here we have just another one. This is a catechism for karma projects, and this is just the questions what need to be addressed. And this is a structure. First is a vision and scope, project statement, proposal, solution, collaboration, knowledge integration, plan. Yes. So we use this to construct projects with and also connections between people. So then, and how it works. So we have it is in this folder synthetic, and here this is the also generated. So first of all, we have all merged research profiles of all participants in this file. So this is a automatically generated file, and the same we have automatically generated description of the intelligence of matter, and this is current understanding, future direction, changes. So this is done in this format, and this is what is known in general. So this is basically generated contracts, but you can also have a look. So this is also maybe interesting to see if you agree or not. And this is basically general knowledge available in the internet about this field. And future direction. So this is again, it is a rapidly evolving with several excited future directions, and those are 7 directions. What basically it is discussed in the literature, so it is not coming from anywhere. And we have also open questions. This is for fundamental science, for computational science, material design, applications, ethicals, and emerging questions. So there are the questions and future innovation. So this is again how to because if we talk in the workshop about intelligence of matter, we need to talk what do we consider it, and this is our actual state. Maybe after the meeting it will be completely rewritten and we have new ideas and they will be doing this. And here is the beauty of this method. So we can be based, everything is based on agents, and then we can regenerate all the structure again. That is not a problem because it takes maybe 10 minutes. After this, we go to participants, and then again, we can pick up the participant. There is, first of all, so we have a research profile. So the research profile that we already saw, there is a research focus of the person. Then we analyze impact analysis. So there's high citations, focus on fundamental competence. We have research evolution from where it started and where this researcher goes. And then there is a key contributions and also future directions with respect to this field, intelligence of matter. So where this profile can fit in this structure what we proposed. And if intelligent soft matter will be redefined, this is fine. Then all those profiles will be again regenerated. And then another one is the collaboration. So we know this field, we know where this researcher come from, and then the question is what collaboration, what is the matching contribution he may search. And here what we see that there are several suggestions to whom he may all collaborate. So it will be complementary. And so this is a totally automatic. And there you can also have a look, and then and after this, a third part. So we have, and a second one is the project. We have methods, so we can extract methods from publications, and then analyzing those publications, we can see that there is a list of methods with a description. With Monte Carlo simulations, and then with the description and the result outcomes. Then we have also several models. So we see all those theoretical models, and we see also emerging trends, how this field evolves, and limitations. For example, if you use scaling models, scaling theory, the renormalization group, what will be the limitations? And this is very useful when we talk about collaboration and projects. After this, we go to project generation. And for example, this is a project generated for this particular researcher. And here what we see is the emergent computation and congruent biohybrid materials networks. So here we see all descriptions. So then starting from the title, they have project rationale and objectives. So this we have according to this catechism what we set up. For example, if we want to structure it in the form of a European project, there is a special setup for European project. If this was done for Karma Gap, and here we see the structure for this particular project. And here what we see, all those topics like alignment with EU calls, project vision objectives, and contribution to priorities, expected KPIs. Then they have state of the art, gaps and limitations, novelty, and then we see also alignment with Europeans. This is, by the way, this is a European structure, methodology, what can be done in this methodology, expected impact and EU added value, and long-term risk management, and all these resources and work plan and deliverables. So this is already we have this dissemination exploitation, so ethics and all these things. So this is a European structure. So we have another project which was done here. So this is another project which is called a different type of project with a completely different structure. And this is simplified. This is Karma Gap projects are simplified. And here we have a vision and scope. We don't have any Europe dimension, gender balance, and all these things which will be very a particularity of the European project. Here it is a vision and scope, why this project needed now, societal need, problem statement, and proposed solution, and key innovation. And what is also important that here we'll also see with this project, which is another type of project, is neuromorphic soft matter by-inspired Meresev network of catalytic nanoparticles. It just suggests a person from the workshop who will be the best contact with respect to this project. For example, here, what is this idea? So we have a neuromorphic integration. So this is, what is this? So this is MEM resistors, and how to make them from soft matter materials using photocatalytic nanoparticles embedded in polymer matrix. So this is the topic. And it was generated, so we have a connection with other participant, and we have a structure already for the grant proposal, and it was generated in 100 seconds. So it's basically two minutes, and you have a project like this, then with full details. And here also what is also included, network and collaboration. So who else from the meeting can contribute to this idea? And here, because we know all the profiles, so they just list those people from the workshop and how these people can contribute to this particular project. And again, we have this methods. So this is again what methods need to be taken into account. They have the STEM, SAM, spectroscopy, so computational data, biological data, machine learning. So then it will be also the structure of the implementation plan. So this is structure of the project. It can be a several year project and how to structure it. And we have a methodology, what else is necessary and what is missing. And you see it says also that not all people from the workshop is enough, that will be again some extra people. This material scientist, engineer, it's missing and we don't have it in the workshop. But if we just limit people from the workshop, it just give you this those names which are more suitable for this project. So this is the way to operate. So this will be just an example. Of course, we can delete this all, and it may not, maybe not. It will be just an example. So this we can use it as an example of future collaboration. So it's for us, it is important that if you can just log in and have a look of researcher profiles, it is also possible to generate for even for each person to whom to talk and to which subject. For example, you can, with your profile, then you can talk to another person and also present something that maybe you don't even realize that you can work together on something on this. And that's maybe we can have a list of people and two topics that you can address those people because they are experts in this field. So this is more or less what we are doing now, and this is how this field is developing. So, and I know that Daniel wants to show something else.
Thank you, Vladimir. That's awesome.
Mm-hmm.
That's cool. Okay, I'm going to show the last piece of the script, and I mean, I hope this is giving some fun ways in each symposia that you all or anyone organizes or we organize. We can keep on iterating and making it more interesting. Okay, let me just share. Take a second. Do you see? Okay. Let me try screen sharing again. I'll just show this for a minute, then any thoughts or questions on this? Okay. It says I can't share my screen. I'll try one more time. Or I'll just share a window. Okay.
So meanwhile, if you have any questions, you can ask.
Let me just reload. I'll be back in 1 second.
This interaction, and this is why we also see a big, a very big potential in nano publications, because this is the way to structure the pieces of information which is relevant, and which you can say this because if you build a project, everything can be generated, but what is important is what is really verifiable data, and what is a statement which is you can trust. And this is where this nano publication comes, because you don't need the whole paper, you don't need to write to read reviews, but what you need is to have those pieces that you can construct your own project, you can construct your own paper or something like this. And this is can be also done automatically. Yes, and this is where we see this interaction between AI, humans, and the system of the blockchain, which is basically what Torres showed. Mm-hmm.
Oh, okay. It's a funny thing, but just navigate over to the ISM stream, and I'll show it on the stream. But just for those in the chat, in the ISM stream, there's a folder 6 called Visualize. And what Visualize does, again, it'll be visible on the stream. I'll run it in Coda 2. Okay, first thing it does is it iterates over each kind of the output document. So the researcher profiles. I know you don't see it in the Google chat, but it's visible on the stream. But it's just a funny thing is happening. But then it iterates over each kind of document, like the research profiles and the other, and then it uses standard set of linguistic analysis methods like topic modeling and principal component analysis. All these will be in the visualizations folder, and so it makes, for example, principal component plots and what those principal components are loaded on for different researchers, and looks at different topic modeling and statistical aspects of the semantics of the event. So that opens up a lot of really interesting possibilities for like designing unlikely connections and setting up projects that are in certain regions, and especially combined with the methods that Vladimir just mentioned, nanopubs. I mean, having a nano CV with available methods, this is really changing the game because of the semantics being openly accessible, and the rate limiting step to a large extent being like what projects are really going to happen with who and how.
Yes, we see Akile first.
Oh, okay. Thanks a lot for this. I got the general picture very clear, and what I don't have clear is how can we refine the results? Because all these results were obtained by automatic information that were in the web. But how do you iterate in such a way that this can be refined? Because this could be all junk, right? In principle.
Yeah, of course, yes. And this is the way. This is just to give an idea of before the meeting of our other participants, and then to see what can be done, and then to refine. It is basically on the field what you want to achieve. Then the structure of the questions what you need to answer, and also the profile, methods profile. So this the basic information. Then because what it does is just the shifting. So, example, if you have a method in polymer physics, and you want to apply it in some elements of quantum theory into polymer physics. So, and you know that this is how De Gennes got a Nobel Prize, and he just could go from one field to another field and bring the tools with him. So this is how it does. So this is just merging different approaches, which is already common in one direction, in one field, and applying to another field. And then this is done with the prompts. This is prompts, and there are maybe 20 prompts which to generate one document, but you see that adjusting it, then you can improve a lot and put more details. It will put a lot. So this is the
short answer there. It's in GitHub. So get people to have editor access on the repo for the event, and then have it just as a starting point and make edits in collaborative fashion in Git, just like anything else.
Okay,
Yeah.
thanks a lot.
And Rudolf.
Yeah, thank you very much for this very interesting presentation. I think that could be sort of a game changer. I will be very open. I do not yet really see how that actually works in practice, but I'd love to try it out. I mean, I'm a little bit. Most of the questions have already been answered because I had more or less my questions headed into the same directions as Achilles. What I haven't got, and that may be my fault, I apologize because I had to go to the door briefly, but how do we operationalize this during our meeting? If I got it right, then we have to prepare something, and we have to.
Yes.
Okay.
Yes, and this is why I prepared the Coda link. So this is a link where you some people already joined the joint publication, because we will have a publication. So it is already assigned topics because they are writing what they want to contribute, and more important that you come already with the idea what other people are doing, what is their contribution, and you can already have ideas of what do you want to write in, and what do you want to say about this field, or maybe this. And that Coda is the way to do it, because then here it just is like a Google document, and then you can modify it, and whatever you want, you just put it there. Text, and after this we will discuss already this draft, because draft is there. We have also the definition of the field is also there, and it is coming from me. It's maybe wrong, so let's say, but it can be also then you can modify it, and also you can change this direction, because what we will also ask a question: what is the minimal version of those AI or this intelligence in the materials, on what are the limitations of experimental limitations. So this kind of things, I invite you to join Coda. If necessary, we can open more documents there, and then you can contribute.
Okay, very good. I do so. No, thanks a lot.
Yeah,
that's amazing, man. To me, it sounds as an experiment, and I apologize, man. See, I'm an old guy, so learning new technologies is always hard for me. But let's try it; will be fun.
Vasil, yes.
Hello. I have a quick question. These profiles that are automatically generated for all works, can we modify them if we think that something is not?
Yeah, of course. Yeah, a text file you can modify it. It will be better, because if you modify your profile, that will be much better, because
and we can access them in the website somewhere. Or...
Yeah, and it can be done like it's in an open. It can be done with access. Yes.
Okay. Thank you.
Yeah, just to share like a funny thing from the previous symposium, a presenter with a name that was shared with another researcher, the Perplexity internet search on their profile was 100% incorrect. So then this person looked at it, sent in an updated manually written version. But that's a short-term type thing, as we're just experimenting on these early iterations, planning more weeks and months out, and then at a deeper time scale, having more updated information and clarity around what's open and what's shared with organizers and organizations and so on, about who's available for what and what's updated information on their nano publications and on their preferences, on their capacity. The more and the more relevant and accurate that information is, enables this kind of decentralized knowledge collaboration using synthetic methods better. So Wherever accurate information can be shared, it's like it'll be leveraged. If the information's not in the research profile, then it's not going to come into play in the later catechism-based grant.
Yeah. So we have now a few minutes before the end. And yes, Vasil.
Just another quick one. Okay, so what is the best time frame until we can update our profiles so the engine will have enough time to process?
Until the meeting, we have roughly 8-9 days. So this you can modify. So this is just a toy model. We will see how it works, and after this, we will see during the meeting. Maybe for sure we will have much better ideas than now.
Okay.
Yeah, that sounds really exciting to have months in advance, clear, streamlined, non-overloading communications, have accurate information, connect people, and then enjoy the possibilities for having connections at events and symposia, given that they're only several hours long, and use the before and the during and the after to recognize and build on all of this amazing work and people who are at different career stages. There's and so many connections with how prior publishing methods, existing grant opportunities, new publishing methods like Nanopub, new grant opportunities.
Yeah, this we will explore a lot because a European grants is not the only option, but now it becomes more and more the decentralized funding that comes from also from this blockchain, and decentralized science is the same. So you don't need even a university to be researcher, and then you can collaborate through such tools. And this is how also Daniel operates this institute, is multidisciplinary and distributed. This is the future, I think. Yes. Okay, so if no more questions, then we meet each other very soon, almost in a week, and we will start with this discussion in live. Yes.
Okay, thanks a lot, Vladimir. Thank you.
Thank you for your time.
Thank you, Dan.
Thank you.
Thank you very much.
Thank you all.